Hi everyone. This problem is problem number 2 from the Chapter 12 written homework assignment. And I just want to get it started for you. I'm not going to do the whole problem for you, but I'll try to answer some common misconceptions about this problem. So first I want you to notice that this table already includes the totals, which are really nice. If you have a contingency table that doesn't have these totals already built in, that's the very first thing that you should do before you start looking at any questions, is to fill in all the totals. So let's look at part A here. It says, if we select a student at random from this study, what's the probability that we will select an 8th grader? So because these totals are built in for us, we can see right here that we have a total of 251 8th graders out of this 478 total students in this study. So the probability that we will choose an 8th grader is going to be this 251 out of 478. Now I know I just did that problem for you, but I wanted to just say that you shouldn't spend any time trying to reduce this fraction. You should write the fraction because the fraction is your work, but you should then write this as a decimal, and the directions don't specify if you should round to 2 or 3 decimal places, so that's usually what I round to, is somewhere around 2 or 3. You don't want to round too much, but you also don't want to put like 5 on there. All right, so for part B, it says, what is the probability that we will select a 3rd grader whose goal is to be good at sports? So first of all, let me erase that. So we're talking about a 3rd grader whose goal is to be good at sports. We have 60 of those students. There's 60 students who are in 3rd grade and their goal is to be good at sports. So that probability would be this 60 over 478. So this is the same as saying that they are in 3rd grade and they want to be good at sports. I'll let you finish that problem. For part C, it says, what's the probability that we will select a 3rd grader or a student whose goal is to be good at sports? So notice now that it's not just these 60 students. It's students who are in 3rd grade or good at sports. So they're in 3rd grade or their goal is to be good at sports, which means that we want all the 3rd graders plus all the students whose goal is to be good at sports. But now these 60 students here that we found in part B, those students are in both of these groups, and we don't want to count them twice. So we need to subtract off this intersection of students who are in 3rd grade and good at sports, because we don't want those 60 students to be counted twice. So the probability that they're in 3rd grade, you're looking at this 227. The probability that they're good at sports, that's this 90. And then you're subtracting off this 60 students that are in both categories. I'm going to write this one out because I think a lot of people overcomplicate this by making them separate fractions or decimals right away. You are adding together this 227 plus the 90 people whose goal are to be good at sports, and then you're subtracting off the 60 people who are in both categories because we don't want to count them twice, and then we're dividing by this total amount. And so if you take this and write it as decimal, you'll have your answer. So for part D, it says, what is the probability that a selected student wants to be good at sports given that we have selected an 8th grader. So we are looking for the probability that they are good at sports, or that they want to be good at sports, that's their goal, given that they are an 8th grader. Excuse me. Technically speaking, this is the probability that they are good at sports and they are an 8th grader divided by the probability that they are an 8th grader. Now, I think a lot of students make this more complicated than it is by having complex fractions. But think of it this way. We know that the student that we are choosing is an 8th grader, which means that we are only looking at 8th graders. We are only looking at this row. And so instead of having a total of 478, we have a new total of 251. So we're only looking at these 251 students, and what is the probability that they have a goal of being good at sports? That would be this 30. Feel like I'm doing too much. I'm giving the problem away here. All right, part E. Again, write that as a decimal. Are the events a student is an 8th grader and a student's goal is to get good grades independent? So we're asking, is being an 8th grader, so 8th grader, independent of the goal of getting good grades? So are those two events independent? And it says you must use a valid probability formula to support your answer. So when we talk about independence, what does independence mean? It means that one event does not influence the probability of the other event. So choose one of these events. It doesn't matter if you choose being an 8th grader or choose the grades goal. It does not matter which one you choose. So I'm just going to choose the probability.